Good day. My name is Heinrich A.C. Fortes from STEM 101, here to tackle about the limits at infinity. So before we start, let us define what is the limits of at infinity, sorry. Limits at infinity. Limits at infinity are used to describe the behavior of functions as the independent variable increases or decreases without bound or bound. If a function approaches a numerical value L, in either of these situations, right, and f of x or y is said to have a horizontal asymptote at y is equal to L. Now, here is how to find the limits at infinity. But before that, I will discuss and teach about the uh, uh, basic basic needs to calculate or formulate the limits at infinity. Let's start with the integers. So let's start with the limit of x squared as x, sorry, as x approaches infinity. So we are just going to change the value of x into infinity. It will be infinity raised to, sorry, quantity of infinity raised to 2. So infinity times infinity or infinity squared is just infinity. Next, for the next example, the limit of x squared as x approaches negative infinity. So we're just going to change the value of x as the quantity of negative x raised to 2. So in the rule of exponent, if we squared or if we multiply an sorry a negative value to itself, it will change from negative into positive. So negative infinity times negative infinity or negative infinity raised to 2 is equal to positive infinity. For the next example, the limit of x cubed or x raised to 3 is equal to sorry, as x approaches infinity. As it is, we're just going to change the value of x to infinity. So the infinity quantity infinity cube or raised to 3 is equal to infinity, because infinity multiplied by another infinity is just infinity, but we can say it is a large number for an infinity. And for the last example, the limit of x raised to 3 or x cubed as x approaches negative infinity. We are just going to change the value of x into infinity sorry, I mean negative infinity. So the quantity of negative infinity raised to 3 or cubed. So for the integers or the negative numbers raised to 3, it is like negative multiplied by another negative by another negative. So in short, if you multiply two negatives, it will turn into a positive number. But if we multiply it for another negative, it will turn into a negative. So I'm just going to erase it. So in the result of negative, negative infinity raised to 3 or cube is equal to negative infinity. Now we're going to tackle or I'm going to teach about the some of the basic um, some of the basic example to find the value of limits at infinity. So let's start with the limit of 5 plus 3x is equal to minus x cubed as x approaches negative infinity. So in the expression above or shown, 5 and 3x are both insignificant to x to I sorry to negative x raised to 3. So because it is insignificant to negative x raised to 3, we can cancel it out. So the given or the example or the problem can be written as limit of negative x raised to 3 as x approaches negative infinity. Now we're just going to change the value of x into negative infinity. It'll turn into negative multiplied by negative infinity raised to 3. Now, I mean, if we cube an negative infinity, it will just turn into, or it will result in negative, it will result in negative infinity. Now, infinity here, multiplied multiplied by negative infinity is equal to positive infinity. And we can just also erase the plus sign or the operation or the sign. And the limit of 5 plus 3x minus x raised to 3 as x approaches negative infinity is equal to pa- infinity. Next. Now, let's start with the limit. Sorry. The limit of 3x raised to 3 minus 5x raised to 4 as x approaches negative infinity. Now, in this problem, both expression or both terms are insignificant to each other. Now, what we will do is find the highest degree of the expression. Now, the highest degree is the exponent 4. So, this term or this negative 5x raised to 4 is our given problem, and we're just going to cancel out 3x raised to 3. Can be written now as the limit of negative 5x raised to 4 as x, sorry, as x approaches negative 8. And as always, we are going to change the value of x into negative infinity. We go into negative 5, change the value of x into negative infinity, raised to 4. Now we're going to simplify or simplify, sorry, negative infinity to raised to 4. So infinity raised to 4 is equal to infinity or positive infinity because uh, negative times negative times negative times negative. Negative times negative is equal to positive. Negative times negative is equal to positive. And positive times positive is equal to positive. Now, we can write it as negative 5 infinity. As now, for the next step, we're going to multiply negative 5 to infinity. So negative 5 multiplied by infinity is just simply negative infinity. And negative infinity is our final answer. Next, for example number 3, the limit of 1 over x as x approaches infinity. Now we're going to change in a simpler explanation, 1 1 1 over x, limit of 1 over x, sorry, as x approaches infinity is equal to 0, because if we try to substitute x by by other number can be shown as, for example, is 1 over 10 is equal to, in decimal, 0.1. And if we change it to 100, is equal to 0.01. So as the value of the denominator, um, the decimal, or the final value is becoming smaller, or at least, because if we put 1 over 1 1 sorry, I mean 10,000, in decimals it can turn into 0.001, and that is why 1 over x is equal to 0. And for the final example, limit of 5x plus 2 over 7x minus x squared. Now we can use the insignificant process. Sorry, I mean as x approaches infinity. Now, as I say earlier, we can use the insignificant procedure or process, because 5x plus 2, which 5x has an exponent of 1, imaginary 1, while at the denominator we can use the insignificant higher degree process or procedure, which is the highest degree is 2. Now we can say that say that 5x that 5x is equal to negative x squared, because we cancel out this term. Then we can change the value of x by 5, is the value of x into infinity, all over negative infinity raised to 2, like this. I'm sorry, this. Now 5 times infinity is equal to infinity, and negative infinity raised to 2 is equal to infinity. Now infinity divided by infinity is equal to 0, because infinity has no exact number, but it is an expression, and expression divided by another expression is equal to 0. Good day again. Thank you for listening and watching me teach about the limits at infinity. Thank you.